This is just one coordinate system. This is, I'm sure as you know, the Cartesian coordinate system. There are others. For instance, in two-dimensional space, you can make a polar coordinate system where for any point P, it's defined by a radius and an angle theta from some arbitrary 0 point. And this angle goes between 0 and 2 pi radians, or 360 degrees. And of course r goes between 0 and infinity, and r is always positive. So that's another way of just describing the same point as we described in our two-dimensional xy Cartesian coordinates system. So that's our 1, 2, and 3-dimensional universe. What you want to do is pick the universe that, and coordinate system that's best suited for the problem that you're trying to solve. So if you were looking at, for instance, a cannonball, well, two-dimensional space might be all that you need for that. You might be able to neglect that the cannonball is moving left and right and just look at how far forward it goes. If you were looking at such things as signals, electromagnetic signals, and you had a signal that varied with time, and let's say it's just whatever it is, it's some sort of noisy electrical signal, where this function here, it might be voltage, it might be current, or whatever, then you might want to look at an infinite dimensional Fourier space. And here we would say that f of t, or voltage or current, is equal to a summation from n equals 1 to infinity of a sub n times the sine of n omega times t. Omega being a particular frequency, n being an integer. Now, if our f of t happened to be a sine wave, a perfectly pure single note sine wave, then our f of t is simply a sine omega t, where again omega is the frequency of the sine wave, and a is its amplitude. So if I have my sine wave, it would be a tall, and the frequency would be well, this would be the period, right, in time, so the frequency would be 1 over the period. If I was looking at a signal that was a square wave, then I would use the same equation, but every other iteration of this, every other harmonic of this would be 0. So I would have sine of omega, sine of 3 omega, 5 omega, 7 omega, and so forth, and I would add all these up, and I would, when I did that for infinite number of frequencies and added all the individual sine waves up, I would get a nice crisp square wave. But that's neither here nor there. The point is, the universe we choose, the coordinate system we choose, are all arbitrary, and we choose the one that gets us the best results for the problem that we're looking at.